3.3 zeros of polynomial functions. We start with the factor theorem, and the factor theorem says something similar to what we've had in the past. For any polynomial function, x minus k is a factor of the polynomial if and only if f of k equals 0. So we're going to try to figure out if this is a factor, but we can do that by using synthetic division, and we're good at that. So x plus 4, we want to look at the 0 value, x equals -4, and we want to do synthetic division on that -4. So check it out. First problem, we would use -4 outside the box on our synthetic division. And then we look at the coefficients. There's 3x to the 4th. Oh, notice there's a missing piece. So put a 0 for the x to the 3rd. Minus 48 for the x squared. There's an 8, and there's a 32. So I think you're pretty good at synthetic division by now. Add straight down and multiply diagonal. 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 Oops. And add straight down. Notice we get 0. Okay. The question, determine whether x plus 4 is a factor, is pretty much the same question as, is this a 0? Okay. So since we get this 0 right here, we know that -4 is a 0, but because of that, we know that x plus 4, I guess I should say yes, x plus 4 is a factor. So ideally, what we're going to end up doing is we're going to use this process to help factor polynomials that we wouldn't have been able to factor before. We're going to be able to deal with a lot bigger polynomials than ever before. So let's look at the next one. We're still using that -4. We've got a little bit bigger polynomial. 1x to the 5th, 6x to the 4th, 11x to the 3rd, 12x squared, 5x, and minus 20. Add down is 1, multiply diagonal. Add down is 2, multiply diagonal. Add down is 3, multiply diagonal. Add down is 0, multiply diagonal. Add down is 5, multiply diagonal. Add down is -40. Oops. Okay, so that number, since it's not 0, I know that no, this is not a factor. X plus 4 is not a factor. Seems simple enough because it seems like exactly what we did in the last lesson. There will be more, trust me. All right. Number 2 says factor this expression, this polynomial, into linear factors given that 5 is a 0. So we've never known how to factor something like this before. We've usually only ever factored something like x squared, or if it was bigger than x squared, it would have had a GCF in it or something. This one doesn't have a GCF. Sometimes we were able to do like grouping, if you remember doing grouping with something like this, but grouping, relies on a GCF, and we don't have a GCF. All they've given me is that 5 is a 0. So what I can do with that information is use the 5 to break down the problem. So think about the division process. I've got 6x to the 3rd minus 37x squared plus 32x and plus 15. Do the same process, synthetic division, add straight down and multiply diagonal, add straight down and multiply diagonal, add straight down and multiply diagonal, add straight down, and you get 0. Okay? We knew it was a 0 because they told me it was a 0. 5 is a 0, so we knew it was going to be a 0. But here's what's happened, okay? We are basically doing a division problem. And so if you're dividing all these terms, you're dividing by, what, x minus 5, I guess. If you're dividing by x, it's going to knock off the power of x. And so that means what we have here is 6x squared minus 7x minus 3. So we've got a new polynomial, 6x squared minus 7x minus 3. And this is something that we should already know how to factor. Now, I find that people are not very good at this sometimes, but we should be able to factor this using techniques from Algebra 1 class. Now, the problem with this 6, I suppose, if we tried to factor this like we did in Algebra 1, it might be 6x and x, but it also might be 2x and 3x. So in this case, because 6 is not prime, you've got two different possibilities, two different ways that we could potentially produce 6x squared. So that just means something extra to think about. Now, look at the last number, negative 3. When I think about this, I know for a fact that those numbers that I put in my parentheses are going to have to multiply to be negative 3. So I will kind of list out the ways to get 3. Okay, it's got to be 1 times 3. Now, I know something's going to be negative, but I'll think about that later. All right, it's got to be a 1 and a 3 or a negative somehow, but I'll think about the negative here in a little bit. The hard part is producing the negative 7. And so what I'm looking at here is I'm trying to find some kind of combination of either 6 and 1 or 2 and 3, along with these numbers, of course, that's going to make that negative 7. So basically, let's look at this first possibility. This first possibility says I'm going to multiply one of the two numbers by 6. If you think about the FOIL process here, the number that goes over on this side is going to get multiplied by 6. So what you would do, or what I would do, is I would kind of just play with the numbers over here. If I had 6 times 1, that's 6. Plus 3 is 9, or minus 3 is 3. That's not going to cut it because that's not going to produce 7. So I know that's not going to be the case. So maybe I try this one times 6. 6 times 3 is 18. Plus 1 is 19. Minus 1 is 17. I don't think that's going to cut it either. And so I am very suspicious of this working at all. I don't think that one's going to work. I think it's going to have to be the other way. The other way, let's see what we can do here. And again, if I'm thinking about the FOIL method, if you FOIL, this number over here is getting multiplied by 2, and this number right here is getting multiplied by 3. So what I would do is I would say, okay, what if I go 2 times this and 3 times this? If one of those numbers is multiplied by 2 and one of them is multiplied by 3, that would be 2 and 9. So if I add those, I'll get 11. But if I subtract them, I'll get 7. I'll get 9 minus 2 is 7. I think that's it. So all I have to do is think about how to place the negative sign. Okay. I need a negative 7. So I think 2 minus 9 will get me there. So I know a couple of things. I know that my 3 is going to be my negative, and my negative 3 is getting multiplied by the 3. So make sure you put the negative 3 in the position that's getting multiplied by the 3 in the FOIL process. So you can always FOIL to double check this. That's going to give me 6x squared plus 4x. Oh, did I do that wrong? Oh, that's not a 2. That's a 1. Duh. Hang on a second. Back up. My numbers were 1 and negative 3. So I should have put a 1 right there. Okay. So FOIL, that's going to be 6x squared plus 2x minus 9x minus 3. And sure enough, that produces what I wanted. And so my two factors are here. All right. But don't forget about this factor. This was one of my factors as well. So if I'm factoring it completely, I would have x minus 5. That was the one they gave me. And then I figured out 2x minus 3 times 3x plus 1. Now, I know students struggle at that problem, but don't be discouraged. The hard part of this problem is something that you probably forgot from a couple of years ago. You should know how to factor. If you've forgotten, that's fine, but we'll have to pick that back up because that's the hard part, the factoring and getting that 2x minus 3 and the 3x plus 1. But that's it for that one.